So we are already done with disjoint set, right? Union, find, data structure we saw, right? We also saw the three different function calls, right? Find, union, make set, right? So now let us see something very important called as strongly connected components, and we'll also see an algorithm which helps us find out the strongly connected components. We call it SCCs. First, let us understand what a strongly connected component is. Firstly, make it very clear, strongly connected component are defined in directed graph method. Alright, in a directed graph, फिर आगे अगर some conditions are there, वो satisfy, then you call it a strongly connected component. But the graph should be directed, right? So that is what I have written here. In a directed graph, SCC is what? So SCC is a maximal subtree. SCC is a maximal subtree. Okay, यहाँ तक it's clear. In a directed graph, so SCC is only defined for directed graph, and SCC is what? Maximal subtree. कैसे? Where every vertex, मतलब subtree में जितने भी vertex है, so every vertex is reachable from every other vertex. So if this is your maximal subtree, every vertex should be reachable from every other vertex. Are you getting it? And it's a directed graph. Remember that. Okay. So every vertex is reachable from every other vertex, obviously within the component. So then you have, so your graph would be very big, but then there's one component which is a maximal subtree, and in that component every vertex is reachable from every other vertex. So then that component is known as SCC, strongly connected component. Is this thing clear? Everyone, yes or no? Super. Now let's move on to the algorithm. So I can give you a graph and I can ask you to find out all the SCCs present or the number of SCCs present. Alright. So the algorithm, let's see KOSARAJUs algorithm. The time complexity is B plus E. O of B plus E is number of vertices and E is edges. Okay. उसके पहले let us see something called as transpose of graph. Can someone tell me what is a transpose of graph? Opposite, you can call it opposite. Anyone else? Exactly. So if you have a graph, right, and उस graph में there are many edges, right? Every edge will be of the form from a vertex to some vertex, right? So let's say if the edge is of the from U to V, it goes from U to V, and there are many such edges. So transpose of the graph is if you go from U to V, right? ऐसे direction में जा रहे हैं, जितने भी edges हैं, all the edges you reverse. Understand this very carefully. So you have a graph, it has many edges, right? Every edge will be of the form V1, V2. So if it is of the form V1, V2, transpose of the graph आप क्या करोगे? Number of vertices, number of edges same रहेंगे, only direction will be reversed. So if it's from V1 to V2, then if you take transpose, the edge will go from V2 to V1. Very clear? This is transpose of the graph. Alright. Let's move on to algorithm. So it is it's a very good algorithm now, and it's a very beautiful algorithm. It works in two passes. There are two passes for that algorithm. KOSARAJUs मतलब two different passes, and it's very easy to implement because it's DFS. Sorry, not DFF. DFS, you know what is DFS? Depth first search. कैसे लगाते हो depth first search? Which data structure you use? Recursion. All right. और अगर कोई data structure use करना है तो stack, है ना? Depth first search. Stack. Perfect. All right. So I hope DFS is a very basic algorithm, right? So okay, and read the top line. Are you able to understand it? Reversing the edges does not change the strongly connected components. Suppose you have a very big graph and there are 3 or 4 strongly connected components. अगर आपने edges का direction reverse कर दिया, strongly connected components अभी भी उतने ही रहेंगे, क्योंकि if this was a component, right, where you could reach from one vertex to every other vertex, right, तो अगर direction उल्टा कर दिया, तो अगर यहाँ से यहाँ एक edge थी, इसका direction उल्टा हो गया, लेकिन फिर अगर यहाँ से यहाँ भी एक edge थी, तो उसका भी direction उल्टा ही हो जाएगा, right? Are you getting this? When, if you understand this, KOSARAJU will be like a cakewalk for you. Do you understand this? Alright? Ki reversing the edges does not change the SCCs, the strongly connected components. Alright, cool. So, reversing does not change the SCCs. It's a 2-pass algorithm. Let us first see pass 1. Very simple. Then you finish the order stack. Right? So what you do is basic. Perform the first search on the graph. ठीक है? बहुत बड़ा सा graph होगा. You know the vertices, you know the edges, B, E. Just perform the first search. Okay? Once you are done with the depth first search, what you do is, as each node finishes, depth first search में आप एक node को लेकर उसको पूरा exploit कर लेते हो, और फिर वो खत्म होने के बाद उसको visited mark कर दो, right? So as each node finishes का मतलब क्या? All of its neighbors are visited, right? While applying DFS, once a node is finished मतलब all of its neighbors are visited, right? Once this is done, you push that node onto a stack. You push that node onto a stack. We'll use this stack later. Alright. So try to understand this now. Very important. Node on top of the stack will be part of the source in the strongly connected component in the condensation graph. समझा कुछ? ये लाइन. Okay. सबसे पहले ना, do you know what is a DAG? Bracket acyclic. Perfect. It's a directed acyclic graph. Acyclic graph मतलब? No cycles are there. Right. So you know what DAG is? Yes or no? Yes, sir. It's a directed graph, but there's no cycle in that graph. ठीक है? अगर condensation graph का मतलब पता है क्या होगा? If you have a very huge graph with, let's say, M connected components, M SCCs, M strongly connected components. This one to be very careful. Big graph, उसमें बहुत सारे N vertices है, E edges है, N vertices, E edges, right? And M SCCs, M for Mumbai, M strongly connected components अगर उसमें है, हर एक strongly connected component को मैं एक अगर node बना दूँ, right? Let's say this is a graph with 2 strongly connected components, C1 and C2, and there is a node which goes from C1 to C2, right? तो उसको कंडेंसेशन ग्राफ बोलोगे अगर आप एक स्ट्रांगली कनेक्टेड कंपोनेंट को एक नोड जैसा रिप्रेजेंट करोगे. Are you getting this? Not easy to understand, but I hope you are getting it. Right? Very big. Now I am just repeating. Listen to me. Very big graph. N vertices, E edges. But उस बड़े ग्राफ में there are M SCCs. M strongly connected components. Each SCC are represented by a node. और उसका मैंने एक DAG बना लिया. Directed acyclic graph. That is known as condensation graph. Understood? Yes. है ना? फिर वो एक node जो है condensation graph में, that one node is one strongly connected component. You are treating it to condense it. It's just one node, but उसके अंदर there will be many nodes and edges. But it will be a strongly connected component. Very clear? Okay, super. So this is what condensation graph is. जो top of stack पे आपने push किया है ना, it will be the part of source SCC. जहाँ से शुरू हो. Exactly. The source strongly connected component. मतलब वो जो node आपने push करी है ना, this node is highest point from which we can reach all other things. Starting point. So in graph terminology we call it source and sink. एक start point होगा, एक end point होगा. So the starting point you call it as source and sink. Understood? In a strongly connected component. Is pass on very clear? सबसे पहले क्या करोगे? DFS लगाओगे. जो भी नोड फिनिश हो जाएगी, मतलब all neighbors are visited, you push it onto a stack. All right. And वो नोड की खास बात क्या है? जो stack के top पे, the node on the top of the stack will be part of source SCC in the condensation graph. And we just saw what condensation graph is. Very clear? Yes. Super. Now pass through is even more easier. Okay. Pass through clear? Let's move to pass through. ठीक है. सबसे पहले क्या करोगे? Reverse करते हैं just to form the transpose graph. ठीक है. Very easy. आपने जैसे भी स्टोर कर रखा है. रिवर्स कर दो सारे एजेस को, तो अभी आपके पास नया ग्राफ है GT. बट वी हैव ऑलरेडी एस्टैब्लिश्ड द फैक्ट कि इवन इफ यू रिवर्सिंग द एजेस डज नॉट चेंज द स्ट्रांगली कनेक्टेड कंपोनेंट, राइट? सो पास टू के स्टार्ट में क्या किया? सबसे पहले ग्राफ को ही चेंज कर दिया. G था, GT बना दिया. U2 भी H थी, V2 U कर दी. बाकी सारे वर्टाइसेस सेम रहेंगे, नंबर ऑफ एजेस भी सेम रहेंगे. अंडरस्टूड? सो पास टू में सबसे पहले क्या करोगे? Reverse to form the GT. Okay, very easy. एक for loop भी लगेगा. उसके बाद you will require while loop, right? While the st not st dot empty नहीं हो जाता, not st dot empty. मतलब जब तक stack empty नहीं हो जाता, is empty depending on which of the so जब तक stack empty नहीं होता, तब तक आप ये repeat करते रहो. Alright, understand very carefully. क्या करोगे? सबसे पहले very simple st.pop. You will pop a node U जो stack के top पे है. उसकी खास बात क्या है? We have already discussed. Then you will pop the node U. If U hasn't been visited, then you start a new DFS. You getting this? जितनी बार भी नया DFS start करोगे, एक नया strongly connected component. Right? So you pop a node, let's say that node is U, and if U is not visited, you start a new DFS starting from U, because U is the source. Yes or no? Yes. So starting from U, and every node, मैंने ये बोला ना, every node in this DFS, अभी U से start करके आप पूरा explore करोगे. So every node in this new in this DFS belongs to the same strongly connected component as you. Understood? Yes, sir. Very clear? Yes. Very clear. Any doubts? Sir, applications क्या है? Applications also we'll see. Applications we'll see. But algorithm में कोई doubt है? पक्का? Let's take a very easy example. Suppose we have a graph G with two strongly connected components. यहाँ पे ऐसे बहुत बड़ा ग्राफ इमेजिन करो, right? एक C1 strongly connected component है, you can reach from every vertex to every other vertex, और यहाँ पे एक C2 strongly connected component है, right? And there exists only one edge from C1 to C2. There exists one edge from C1 to C2. Obviously no edge from C2 to C1. And this is the step. इसमें आपको SCCs find करना है. तो just imagine अगर pass 1 pass 2 लगाओ तो क्या होगा?
सेम चीज ही बन के
स्टैक पे सबसे ऊपर की कौन सी नोड आएगी? पास 1 के बाद स्टैक पे सबसे ऊपर कौन सी किस कंपोनेंट की नोड आएगी? C1 की. बिकॉज़ आप वहां से एक्सप्लोर करना स्टार्ट करोगे तो H तो C1 से C2 एग्जिस्ट करता है. तो आप C2 पहुंच जाओगे, फिर C2 पूरा DFS से एक्सप्लोर कर लोगे और फिर वापस आओगे. तो नोड के तो नोड के टॉप पे कौन सा, अपना स्टैक के टॉप पे कौन सा नोड होगा? सोर्स. बट इट विल बिलोंग टू C1. राइट? नाउ पास 2 में क्या हो जाएगा? सारे एजेस रिवर्स हो जाएंगे. तो C1 टू C2 एक एज थी, वो अभी C2 टू C1 हो गई. तो अभी C1 से C2 जाने का रास्ता है ही नहीं. Are you understanding? Second pass में C1 to C2 was there, but second pass के start में you reverse, So it became from C2 to C1. Now node के top पे there is a node from source node which belongs to C1. You will perform DFS, but आप C2 में कभी घुस ही नहीं पाओगे ना, क्योंकि there is no edge to go to C2. So then वो source से पूरा DFS perform हो जाएगा, तो आपको C1 पूरा मिल जाएगा एक strongly connected component. फिर कोई और node से आपको new DFS start करना पड़ेगा, फिर वो एक अलग SCC बन जाएगा. इसीलिए every node in the DFS belongs to the same SCC as you. But एक बार पूरा DFS खत्म हो गया तो वो पूरा strongly connected component खत्म. Understood? Very clear? The great applications from it for this. See, graphs के applications now are usually in the field of, let's say, transport, right? Wherein roads are edges, cities are vertices, routers, computer network applications. है ना, routers are nodes, and if there is a internet connection or something of that sort. If I give you a very cool application of SCC, no? So it's something which I like is it's used to identify something called as circular economy. पता होगा क्या?
Circular economy.
अच्छा, money laundering तो पता होगा.
Yes.
Money laundering सबको पता है. So it is known as, in circular economy, it is known as whitewashing.
Whitewashing.
Whitewashing, you know?
Yes, sir.
It's also known as round tripping or wash trading. So what people usually do now, let's say they have 10 different shell companies and they want to transfer 10 million. So what happens is A sends 10 million to a shell company B, B sends it to C, C sends it to D, so on and so forth. But again it comes back to A.
It is complete.
So if you apply KOSARAJU there, you can identify. See, if your transactions are legal, right? So a transaction from A to B, a transaction is basically, it should be from a source to a sink, right? Yes or no?
Yes.
Source is usually the investor, sink is vendor or something. But if someone is doing something fishy, नाम क्या बताया मैंने? Round tripping or wash trading. Wash trading. If someone is doing something like that, so you can apply this algorithm. And if there are 10 different shell companies, this algorithm will identify strongly connected components. And if there are strongly connected components, then you know they are exchanging money amongst themselves, right? So then you can identify. So that is usually using KOSARAJU. So it has great applications in finance, right? So why round tripping का मतलब ना, what companies try to do is they try to, why do they do it?
To convert their black.
That is one thing, but ये पैसा मिलता रहता है पर उन्हें तो करता है, so it creates an illusion for that particular stock that it's highly liquid. You getting my point? जबकि वो पैसा एक ग्रुप में होगा, right? So wash trading or round